In this video, we're going to try to link a little bit of the old news with the new news. So a little while back, we discovered that we had some intersecting lines which formed interesting angle pair relationships, like angle 1 and 2, were adjacent angles whose sum was 180 degrees. We called those a linear pair because they formed a line. Of course, here's another line. Angle 2 and 3 are a linear pair. 3 and 4 are a linear pair. 4 and 1 are a linear pair. Also, we had this idea of vertical angles. Two angles that formed an X and were opposite each other. So angle 1 and angle 3 are vertical. 2 and 4 were vertical. And vertical angles were always congruent. These guys added up to be 180 degrees. Now we're going to take that and we're going to put some more firewood on the fire. So we take a look at parallel lines. What are parallel lines? Go ahead, press pause, get into your notes. They are two coplanar lines that do not intersect. Arrows are used to indicate that lines are parallel. These extra arrows right here are used to indicate parallel relationships. And the symbolic notation is that line AB, remember our notation, is parallel to line CD, where these vertical lines are parallel. So make sure you get all of that into your notes now. Again, press pause, copy all this into your notes. Now, just like we have parallel lines, we also have parallel planes. So you got plane J, plane K, remember our script letters. Planes that do not intersect would be considered to be parallel lines, just like coplanar lines that don't intersect are parallel. Planes that do not intersect are parallel. Plane J, parallel to plane K. Press pause now, get that into your notes. Now this will probably come as a new vocab word to you, skew lines. What are skew lines? Skew lines are non-coplanar lines that do not intersect. So there's two types of lines that don't intersect. Non-coplanar are called skew. Coplanar are called parallel. So let's get an example. We got PS running this way, and then segment VR running up and down. Now this up and down line is never going to intersect with this line going back and forth, so those are skew. Okay, how about TW moving back and forth with segment UQ right here going up and down? They're never going to intersect. Or how about PT going up and down? It's never going to intersect with QR. Those are all examples of skew lines. I would copy this figure and this into your notes. Next, let's take a look at this figure, which I would probably press pause and copy a quick one into your notes. Just a quick note on how to do that fast is just to draw two sort of parallelogram looking pieces here, and then connect, 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 and connect. All right, name all the segments parallel to AE. Now, all the segments parallel to AE are all the ones running up and down, just like AE is. So you got DH, BF, CG. Segments BF, DH, and CG. Right? And notice that segment notation, segment notation, segment notation. Next, we have examples of parallel planes. Now, first, I'll go with the example names. Plane ABF. So, plane ABF is the front of our figure here. So, sort of this front piece. And who's the front parallel with? The front's going to be parallel with the back piece. So that's plane DCG, right? DCG is the back, and the front ABF. And then the last question asks, name all of the segments skew. Now let's just name a couple. I think there's just way too many. So first, let's go find segment GH. So segment GH is left to right along the back. So who's not going to run into anything going left to right along the back? How about up and down in the front? So segment EA, right here on the left, segment BF, or FB, on the right. And that's good enough. AD, of course, is running front to back on the bottom, and EC also will not intersect with that line going left to right. But I think naming all is sort of a little egregious. Naming a couple is sufficient. For this next section, you don't need to copy the picture. I just need you to answer all of the questions. So first, name all the segments parallel to JK. Well, let's go find JK. Here it is, running sort of diagonally along the bottom, right? So who is sharing a similar plane and running a similar way? There's only one answer here, okay? The next one is name all the segments parallel to NS. So let's see, we got NS running back and forth like this. Now there's 4 answers. I'd like for you to come up with 2 of them. For C, name a plane parallel to JKL. So JKL is this plane right here. So let's just copy the whole thing. Who's the plane that's parallel to that? Well, guess what, folks? There's only one name there. Don't forget to use the word plane before you name it, and it needs to have 3 letters. And then don't forget here for your 2 segments, put the segment bar notation over it for that one, segment bar notation. And then at the end, name 4 segments skew to RQ. How about we just name 2, right? So over here, we're just going to name 2 segments here. 2 answers here, 2 segments, and skew to RQ. So let's go find RQ. It's running downwards like this. 2 lines that will never intersect with that segment and also don't run in essentially the same one. So one that you don't want to name is segment ML. ML is parallel, right? Segment ML is parallel to RQ. So no, they'll never intersect, but they're parallel. We want never intersect and essentially don't run in the same direction. Now comes the real meat and potatoes of the deal. It's an interesting phrase, meat and potatoes. So first I want you to copy that picture right into your notes. So draw yourself a line L that looks like that, a line M that looks like that, and purposely make them not parallel. Then let's drop another line down here, and we'll call that line T. And what that line is a transversal, right? What's a transversal? Transversal is a line that intersects 2 or more lines. So who's the transversal? T is. This line right here. That's our transversal. It intersects line L and it intersects line M. It intersects 2 or more lines. So line T. Copy that picture and that definition into your notes. Then, before we even get going, I want you to press pause and copy this picture and all of these into your notes. And we want to do this by hand. It's important that we run through this by hand. So press pause, copy that in, especially the definitions, and then I'll go through them. Okay, so first and foremost, corresponding angles. So to understand corresponding, I like to think about maybe like twins, right? So you got this guy right here, and then you got his twin brother right here. And so who's the same as this hand on that brother compared to the other brother? This hand. They would be corresponding hands, right? What are they? Corresponding angles are angles that occupy the same side of the transversal. So let's talk about all the angles on this side of the transversal. They're on the same side of the transversal in the same position, meaning with respect to line L and M. So 1 is to the left of the transversal and above L. 5 is to the left of the transversal and above line M. So angles 1 and 5 are corresponding. Now, as you notice, so are 2 and 6, 8 and 7, or I'm sorry, 3 and 7, and 4 and 8. And so how do I know that? Take a look back at the picture, and let's keep color coding. 4 is to the left and below L. 8 is to the left of the transversal and below M. 4 and 8. Then we got 2 is to the right and above. 6 is to the right and above. 2 and 6. And then lastly, the last angles standing are 3 and 7, both to the right and below. 3 and 7. So there's our corresponding angles. Now we move on to alternate interior. Okay? Well, for interior, it's kind of like looking at the sandwiched angles inside the 2 lines. Those are our interior angles. And they are going to alternate opposite sides of the transversal, and they're also going to be one from group A, right? And by group A, I mean like there's group A here and there's group B here. Notice group A is just like that original set of linear pair and vertical angles we used to talk about. And then there's another set here, right? So I always say like group A and group B. So if I look at that, I'd say, well, 4 is from group A. Now I got to go to the alternate side of the transversal and from the other group. 6, so diagonally. And going by that, I would also say then I guess 5 and 3 are both alternate interior, right? So there's 2 pairs of those guys. All right, so we got 4 and 6 and 3 and 5. Now again, rolling with that same idea of being on one from group A and one from group B, right? So we got a group A and a group B. We're going to move on to alternate exterior. So if these guys were the interior, then I guess the exterior would be 1 and 2, 8 and 7, and we're going to go on the diagonal again. So 2 and 8 are alternate exterior, 1 and 7 are alternate exterior. So again, that's 2 and 8, 1 and 7 are the alternate exterior. And lastly, consecutive interior. So again, we're back to our insiders, right, in here. And consecutive means one right after another. So interior angles that are on the same side of the transversal, one from group A, one from group B. So that leaves us with 4 and 5 are both on the same side. And then 3 and 6 are both on the same side. So those are our 2 pairs of consecutive interior. So 4 and 5, 3 and 6. So again, just to run through that, corresponding angles, 1 and 5. On the same side of the transversal, occupying similar locations to the 2 lines they're next to. Okay, then we got alternate interior, alternating on the diagonal on the inside. Then we got alternate exterior, alternating sides of the transversal on the outside. And then finally, consecutive interior, same side on the inside. All right. Now again, this is a very old style note-taking exercise, the kind that I grew up with, which helps you really truly learn everything because you're writing everything into your notes, which helps pass all the information by and helps you retain it more rather than just being given a bunch of handouts and half filling it out and half paying attention. So what I want you to do now is to take your notes, recopy this last picture, right, and name the type of angles that 1 and 8, 2 and 3, angles 5 and 7, 2 and 7, 1 and 3, 6 and 7. Get that into your notes, and that's your last assignment. Wrap that up, and we'll see you after the notes are done.